Okay, let's look at the halo versus the red phasal inductor.
I'm going to do a little comparison for his new.
Because we're going to talk a little bit about wad modification.
Which is basically wound and the same specs as a halo.
Okay, you can see here that he's put terminals where you can drop components in here to change the values. You know, he did it for the transistors too, which is interesting.
So this one's wound for 550 mH, and this circuit's basically kitted out exactly the same as a McCoy circuit. The only difference is I've got a Q control with a set value resistance at the minimum, so that there's a minimum amount there, so that you get an effect sweep on minimum. Everything's vintage spec, polystyrene caps, tropical fish caps, BC109Bs as the transistors, and basically I'm going to pit it up against one of my other circuits which is identical exactly, except the inductor, and this one's got a red phasal, reissue phasal. All the specs are exactly the same, same wire pot specs, exactly same specs on the Q control, all the same resistor and capacitor.
Hurry
specs.
up, you red coat.
It's identical apart from the inductors, so we're going to give them a blast and see how they fare up against one another. The inductor, the halo inductor, is wound for 550. I read that the red phasal should be around about the same kind of specs. I've got another halo which is hotter at 680 mH, and I'll be pitting that against the yellow phasal, which again,
halos do tend to be a little hotter, I think.
Above 600 figures on the mH, so that'll be a comparable kind of test to AB one another. So
tropical
we'll plug
fish
all these
caps,
in, and we'll see how they fare with one another. And I'll select the Qs, and so that they're identical, and then we'll tweak them and see how they react to Q control. Kit wise, I'm going to be running through my Vibrolux reverb, the new Fender 68 Custom Series. Volume's going to be on 4, treble and bass is going to be on 5. I'm going to be going through the custom channel, which is the bass thermostat, and bright switch is going to be off through input 1. The only difference to my amp to a stock one is I've got 2 Jensen Alnico reissues, the P10 Qs, which are rated 40 watts each. Make it behave and feel a lot different to the ceramic speakers that come in them as a standard. It's been rebiased and has got tube amp Doctor wing Cs in the power section. Okay, right, this is my clean sound, neck pickup, tones on 10, guitars on about 6 and 7. Q controls at halfway. That's the halo.
It's the halo inductor. Here's the red phasal. Here it's a little harsher.
So both of them are true bypass, so you shouldn't be degrading the signal going from one into the other. The red phasal's on the left, obviously. You can tell it's a bit thinner, a bit less balls, a bit more treble, but not as clear as the
My ear, it sounds harsher. The halo's more of that mellow fucking sound.
Neck pickup still.
Alright, so I'm going to stop at that there. And I'm going to go back to some of the modifications here. Hey, sorry guys, I'm fucking losing my shit. Alright, there we go. Alright, so we're going to talk about some of the modifications here. The vocal mod that I was talking about earlier is the 33K resistor that's in parallel. Well, on a Vox board, it's not really like right next to the inductor, but on a Crybaby, you can see it's right here. Let me see if I can zoom in on this better. Okay. All right. On the Crybaby, you got the 33K right here next to the inductor. And then on the Vox, you've got it down here. Okay, that's your vocal mod. So let's talk a little bit about that. This guy usually gets replaced with a 68K. I've some Clyde McCoy pedals have 100K in this position. I would suggest going with a 68K. And they're saying this gives more vocal quality to the wah. Some Clyde McCoy wahs had 100K resistors here. Exactly, that's what I just said. So I wouldn't go with 100K. I know a lot of guys will try 100K and then they go, and they back off from it. So 100K is kind of your tops on there. Of course, this resistor should be matched to the inductor anyway. So I would assume the hotter the inductor, the more resistance you'll need. So then you got the gain and bass response, which is the 470 ohm. That's why this says 470R. Here it is on the Vox, right here. Okay. And on the Crybaby, I think it's this 390 ohm resistor. Yep, they say some have 390 at the emitter of Q1. Now Q1 is one of the transistors. Okay, so they're saying replace the 470 at Q1 with a lower value. This increases gain, which is useful if you converted to true bypass. The bass response is also increased. So if you want a bass response as well as a gain increase, you're going to decrease the value of that 470 ohm resistor. So, you might want to try something in the 200 ohm range. You might want to try something in the 300 ohm range, They're saying 270 to 330 to start with. That's, yeah, I would say that's probably about right. I don't like changing it too much. I would actually stick with probably a 330, something like that. Okay, then we got the mid-range mod. The mid-range mod is the 1.5K resistor between the base of Q1 and the inductor. They're saying you want to replace this 1.5K with a larger value. They're saying try 1.8K. Right here they say try 1.8K to 2.7K. Yeah, why not, right? It says this increases mid-range and helps if your wall sounds dull and muted when you rock the pedal back. Sometimes that can be just it needs adjusted. You just need to adjust the pot, the little armature on the pot, and roll the pot back and then plop that armature back in there. A lot of times that's all the pedal needs is an adjustment with that. So it says higher values than stock also smooth out the bass treble transition. Most people refer to the 33K as the Q resistor, but this resistor also affects Q. So a lot of people refer to this resistor right here, again the 33K that's in both of them, they refer to that as the Q resistor. And you know, you can take that resistor out and actually wire a pot back to the position of this resistor. I would suggest maybe like a 100K pot would be a good idea to wire back to this. Or if you wanted to make it just a little bit adjustable Q control from stock, you could use a 50K and work it with that. But long story short, that would be your Q control. So, you know, remove this resistor, wire it back to a pot, and you got a Q control on your wah. It's that simple. There's nothing really fantastic about wah technology. Okay, so then we got the sweep range, which is kind of important, especially if you're converting your wah to a base wah, but most of us aren't. A smaller value makes the wah sweep more trebly, whereas a higher value is going to make it, you know, bassier. So, you know, discretion with that. A lot of people, you know, can screw things up by changing the sweep range capacitor. I've seen it. Okay, so if you converted to true bypass, replace the 68K input resistor with a lower value, say 47K. This gives a slight increase in volume. Too low a value is likely to result in the pedal picking up radio interference. This can be addressed by adding a small capacitor, 10 to 20 PF, between the collector and base of each transistor. It's, you know, I don't think lowering it to like a 47K is going to, you know, pick up radio interference and stuff, but it might. I'm not sure. Okay, then you've got the wah volume pedal mod. It says lifting the earth connection of the 4.7 UF capacitor will cancel the wah effect and will leave you with a volume pedal. So that's actually a good mod to put on a switch. You know, you can basically take the ground of that, run the ground of that capacitor back to a switch, and then just cut the ground to that capacitor, and it'll effectively take that out of the circuit so that you have a volume pedal. You know, just another weird mod that you can perform. This actually doesn't cover. Let's look up. Well, I guess I'll take you back to the inside of his pedals, because he had them done the way I would do it. Let's see if I can get a better picture of. Okay, now you see where that 33K would be right here. This board actually provides another set, like the resistor would be right here, but this board actually provides another set of terminals for you to do a Q control right off the bat. But basically, you're removing this 33K and you're wiring this back to a pot. And here's his pot. He's got another resistor off of the pot to make his pot a different value, I would assume. And that's your Q control. So it's really that simple. There's not a whole lot to that. You can see this is the halo inductor. He's used a tropical fish cap in here. He's used some old, these look like they're probably silicone cans, but they're old. He's probably selected these based on their HFE gain value. Some guys would recommend changing everything changes the sound. I mean, I wouldn't change transformers. I think it's too much, or transistors. I think it's too much of a pain in the arse. But hey, everybody's got their own cup of tea they got going. I'm going to show you guys some more here, though. Okay, so this is from Stinkfoot in Sweden, and he's saying the first part of the mod need not be blah 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 blah. He says I always remove the buffer stage, so do that to yours as well. Now that's this right here. Let me see if it's going to bring us up a bigger picture, sorta. Okay, that's this right here, and you could see that on the pedal that I showed you guys earlier that I had removed the buffer from the pedal. Okay, so it says blah blah blah. Replace the 390 ohm gain resistor. Let's see if we can get this in. Okay. So here's the 300 and I think this is the 390 gain resistor. Wait. Okay, so he's saying lower the. Yeah, so he's saying he only lowers this a little bit to a 330. So it's a little increase. He's not going crazy with that modification, and I like that. I like more close to original value mods so that you get that tone, but it's not, it's not screwing with anything. Replace the 1.5 mid Q resistor, and that's this guy. See if I can. That's this guy. Okay. Replace that 1.5 with a 1.7 or a 1.8. Again, very similar to what we were just reading on the other one. I just wanted to give some perspective here on what other people have discovered, because not all of our opinions are the same. He says change the 33K resistor in parallel with the inductor for 68K. That's usually what I do instead of doing a pot, but you can do a pot. If the sweep cap isn't stock, 0.01 UF 103 value, for instance, it says the Jimi Hendrix 1 wah has a 0.022 UF here instead. Replace it. I have the Jimi Hendrix wah. It sounds pretty good, but it's not too different from the regular Crybaby. And Jimi Hendrix never played with a Crybaby. He played with a Vox, so it's kind of funny to me. But anyway, all marketing, I guess. Says now I prefer to use trim pots for the 3 resistor changes, as they let me fine-tune the pedal's response to a particular rig, but I always seem to set them above the mentioned values as a starting point, and then I find that I rarely touch them. So changes are you'll be able to find with mixed value resistors. If you want to use trim pots, here are the ones to get. All the trim pots are 10mm horizontal type. The exact values are, or the values, etc., are gain base 470 ohm. Clip the blah blah blah. You can clip the CCW leg, leaving only the center and right legs in place, so the trim pot value decreases as you turn clockwise. Mid Q 4.7K ohm. Here we clip the CW leg instead, making the value increase as you turn it up. Note that a transistor needs to be stood up to make room for the gain base trim pot, and the mid Q pot has to be installed upside down, again to make it fit into the component holes. Blah blah blah. Also in the pic, the 68K input resistor has been replaced with a trim pot, this time 100K. It's set up the same way as a gain-based trim pot, so it decreases in value as you turn it up. but I find that I rarely change that one out of its 68K starting position, so it's not terribly important to fit one. Also, I adjust the pedal's mechanical sweep range, as described here, from the stock position, assuming it hasn't been... See, what he's talking about there is the armature and the pot, okay? I usually end up backing the pot up one notch. I do the same thing, man. I do the same thing. I always test it through an amp first, though, to see if it actually needs... so that I actually need to do it. That's just testing your range on it and going, I like my sweep. My sweep's good. You either like your sweep or you don't like your sweep. And then he says for the true bypass mod you need blah 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 blah. Okay. Okay. Then you've got the LED mod. You know, because you let's say you wanted to add an LED to a crybaby. Okay. And this is all just basically true bypass wiring and adding a adding an LED off of the true bypass wiring. He's saying he's tapping off the voltage from here. He says, well, the simple answer is just steal the 9 volt from somewhere, add a current list, blah, 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 blah. If you don't do it right, you can introduce adapter noise to the signal and or get thumps when you turn the pedal on and off. So here's how I do it. I only do this mod to pedals with power jacks incorporated into the circuit board, revision E or later. Not because the LED draws that much power, but because those pedals have polarity protection and extra filtering built in. The trick is to steal and return the power from the outside of the filtering so that any thumps created when the LED lights up or shuts down will be eaten up by the filter capacitor instead of being heard by the amp. The first step, therefore, is to locate the point where we can steal the voltage needed. On reference, revision F and later WAS, the positive and negative power can be found at the north end of the resistor and the diode, respectively, which is located below the adapter jack. From the resistor, run a wire to the anode long leg of the LED. The long leg's the positive leg. On revision E WAS, pick to the right, the idea is the same, but points are slightly different. So he's saying on revision E, your positives here and your negatives here. Okay? The positive voltage point is still the north side of the resistor, very close to the adapter jack this time, so be careful, blah, blah, blah. But the negative is now on the south leg of the diode. Solder the current limiting resistor anywhere from 1K to 10K, depending on how bright the LED is itself and how bright you want it, to the cathode short leg and connect it to the switch. The larger the resistor value, the blah, 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 blah. Then he's saying you can use an LED bezel, da-da-da. And he's saying here's how you wire the switch back. Give you a close-up of that. Okay, and this is your basic, you know, this is your basic 3 PDT switch wiring. Here it is again. So this is the, he's saying this, it says simple range adjustment, and this is what we were talking about earlier. Basically what you're going to do is you're going to unscrew this, not completely, I just loosen it, and then I push this to the left, so it'll swing over here to the left. Then you're going to adjust, you're going to twist that pot this way, okay, counterclockwise, and then you're going to reattach the arm. It's only gonna move like a couple steps in that direction. If it moves a bunch, you know, in the direction you're turning it, you're moving it the wrong way. Okay? And you really have to pay attention to what's happening to the pot when you move the pedal up and down. You'll see this guy goes like this, okay? So to adjust the sweep, what we're doing is we're turning the pot manually without the arm attached to it so that it's going to be in a certain position when you reattach the arm. That's all you need to know. That's how you adjust your sweep. That's 90% of the time when somebody's bitching about their wah-wah pedal not working correctly, that's what it is. Okay. Then he talks about the gain mod, the vocal mod. We already talked about that. 33K resistor in parallel with the inductor controls the Q value, how sharp the resonant peak of the circuit is, Raising the resistor value makes the peak sharper with a smaller Q value, which in turn makes the wah sound more like wall. Sharper wah might more easily push a clean amp into distortion, though. I normally replace the 33K with the 68K, but feel free to experiment. He says this cap controls the frequency range. A lower value shifts the whole sweep range higher in frequency, while a higher value lowers it. To shift the wah downwards, using more of the woofy bass wah sounds, try a 0.015 or 0.022 cap here. The Jimi Hendrix and Jack Wild wahs have the 0.022 UF here instead of a 0.01 UF. Some Hendrix pedals also have two additional capacitors located next to the adapter jack. And the mid control. Here's where we're getting into inductors. This is a red phasal, obviously. It says, here's how a reissue phasal inductor fits, blah, blah, blah. It only has two connections and will fit in two specific holes, so it's quite easy to orient it the right way. You may have to use the desoldering braid first to clear out the solder pads you want to use. You know, usually all I do is I heat up those pads, and it takes some effort. I guess over time you learn how to do it without using a desoldering tool, but I don't even desolder it because I'm afraid of screwing up the pads. So I basically heat up the solder, I pull out the old inductor, and then I heat up the solder again and slide the new one in using the existing solder. I just feel like I have less of a chance of damaging pads when I'm not sucking solder off of the board. Less heat, less chance of damaging things, guys. He's saying you might have to use a desoldering braid at first. That's a big copper braid that you can put on there to pull off the solder. It's just not necessary. It's only two connections. It's 4 when you're taking the old one out. So basically you want to heat up two sides of the inductor, and then you kind of lift that side out like this, and then you heat up the other side. And it comes out so easily, though, that this is, in my opinion, it's kind of a pointless step. Says you can use this information to fit any inductor you like, as long as you keep track of which pins and the two main ones on the inductor. You should be able to match them to blah 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 blah. Also in the revision 1, Crybaby comes already with a red phasal, but it has a slightly different circuit board layout around the inductor. I haven't gotten around to mapping that one out yet. Okay, true bypass mod. Okay, it says before 1990, all Dunlop wah pedals had wires between the jacks and the PCB. In the mid-90s, Dunlop changed the PCB design and started soldering the jacks directly onto the circuit boards. The earlier type of pedal is quite easy to modify for true bypass, while the ones with the circuit board mounted jacks are a little harder. Also, from the mid-91 onwards, a buffer circuit was added before the actual wah circuit. It's there if your PCB says revision F or higher on it, to help with some of the tone sucking. The buffer's basically there to help with the fact that it's not true bypass, so when it's off, it's sucking your tone, supposedly. I can't. Whatever. The buffer is no longer needed if you mod the wah for true bypass, so it can, or dare I say, should be removed. The current revision is revision 1, which has a different circuit layout around the inductor, which is the red phasal reissue, by the way. Other than that, it looks pretty much like revision G and H wahs that have been running since mid-92, blah, blah, blah. There's no real difference between G and H other than the color of the circuit board. Revision F, which appeared in 91, had a different adapter jack, but that's the only real difference between G and H. Revision E units have a slightly different layout and have a special section below. Please note I haven't bothered to write any instructions for pedals in the older revision E, blah, blah, blah. Okay. Okay, so this is the buffer, and he's saying these are the buffer components right here. I wish this was bigger. I already got it at 150%. But okay, so this transistor, these two resistors, these three, and these three All these components have to be, these 6 components should be removed. Okay. And in this circumstance, I would use a solder sucker, you know, but you don't have to. You just pop them out. It says cut yourself 2 pieces of wire, thin, flexible, multi-strand type that are long enough to easily reach the switch from the PCB. Blah, blah, blah. Then carefully solder one of the wires on the far left hole as seen from the component side of the 3 vacated by the transistor. If you follow that trace, you'll see it ends up at the north side of the 68K input resistor. So this is your new input, basically. We're bypassing the, okay? Well, sort of bypassing the input jack's fucking, what it's got going on. So, bang, bang. The other wire, which is blah, 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 you can connect it to any ground point, but the south hole vacated by the top of the left resistor is a good place as any. This is revision F, G, H, and I. He says, as aforementioned, I strongly recommend removing the buffer stage as it was never part of the original wah circuit. But if you absolutely want to keep it, for instance, if you don't want to change the stock sound at all, here's what you need to do. With a small, sharp knife, carefully cut the trace between the input jack, bing, and the buffer input capacitor. This step cannot be omitted. If you don't cut the trace, the pedal will not be true bypass, regardless of the switch wiring. Again, you need a piece of wire, thin, flexible, blah, 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 that is long enough to easily reach the switch from the PCB, yada, yada, yada. So you're going to just attach it here now. Okay, so that makes it a little bit easier. If you want to keep that, but I wouldn't. I would do what he said before, and I would remove the buffer. Again, this is on stinkfoot.se. You can read all this for other revisions. I don't want to get into every fucking revision of this pedal. You know. And he's showing you how to wire a double pole, double terminal switch, not a, because these are better made. These are the Carling switches, and they are so much better. But if you bought a 3 PDT, you just ignore the 3rd row of soldering lugs. Ugh. So those are our wah-wah modifications. The other thing I wanted to show you, okay, so this is the Clyde McCoy wah. This is our little schematic of the Clyde McCoy. There's our 6 seat right here. You can see our input, output. Here's our 0.01 cap. Here's our 68K. Here's our inductor right here. That's the 500 mH. They have 100K in line. I believe these components are colored in red because some were different and some were, you know, most of the time that's a 68K, not 100K like we were talking about before. Here's some pictures of the original Clyde McCoy. You can see the inductor looks an awful lot like, obviously it's a halo, right? But it looks an awful lot like, you know, the ones that you know, these guys are selling. It's very similar in nature. Some of them have cans over them, blah blah blah, but it's pretty similar. Okay, let's get another shot. Again, a real simplistic circuit. You know, there's not a whole lot going on. And you can see, you know, some people think, oh yeah, those tropical caps make all the. Nah. You know, I mean, I would replace those with film caps and or poly, and I'd be probably fine with that tonally. I wouldn't worry too much about that. You know, I've seen guys put paper and oil. You know, it's funny to me because it's more about the value than it is what the component's made of. You can see this is this is one that was built in 2002. He still put those tropical fish caps in there, but he's using just an axial capacitor for that. And looks like these are polystyrene capacitors from the 70s, and they're great for sound applications. I highly recommend those. They're a little bit hard to find now, but they're great. So this is with an output buffer. You know, you can kind of use because the Clyde is so, and this is just what I do. This is my theory, my sound theory, or whatever you want to fucking call it. Because the Clyde is so popular, and so many guys like the Clyde. I kind of tend to stick with, you know, the Clyde values being sort of my baseline, and I go from there. You don't have to do that. You know, do whatever you think sounds good to your ear. But for me, the Clyde is the one. And yeah. They're saying a common problem is that the wah pedal simply won't wah when put in series before a fuzz pedal. Ultimately, this is the way it sounds the best to most people. The problem can be solved by adding an output buffer to your new McCoy clone, which won't alter the tone of the pedal. This is a simple JFET buffer that's based on the Wah Wah project, tone pad, yada yada, which can be added to. So it's a little boostial, you know. The input impedance of this buffer is set by the 1M resistor of the gate JFET to ground. Since the buffer can give you a slight volume boost, told you, a 100K trim pot is on the output of the buffer to act as a volume pot, so you can keep the volume of the wall pedal at the same level it is when it's off. Blah blah. So here's your trim pot, 1 UF, a 4.7K, a 1M resistor, 2N5457, really common silicon transistor, and a 0.05 UF. Okay, interesting. Okay, so let's go through some of this shit here. At the input of modern wah pedal circuits, the 68K input resistor comes before the input capacitor. In the McCoy circuit, the 68K input resistor comes after the 0.01 input capacitor. This doesn't make any difference in the sound of the circuit, but it's unique to the older wah pedals. So they're saying, you know, that's not something that you have to, it's not going to change your sound, it's just a different positioning in the circuit. Some of the Clyde McCoy wahs had a 100K resistor paralleling the inductor, while others had the standard value of 33K. Now, this has been debated for years of why they did this, why some of them have 33 and some have 100. And I think it was just like they ran out and they, you know, it was whatever was in the parts bin, which was common back then. It wasn't like, you know, they were obsessing on this stuff. If it worked, it worked. Okay? The inductor on circuits that I've seen are halos, both large hole and small hole versions. The closer the inductor is to 500 mH, the better. Once again, remember that. The closer it is to 500 mH, the better. Now this guy is 570. So like with a red phasal, for example, let's look it up. Guess I should have had this prepared beforehand, but let's take a look here. See, they're not saying, I feel like they don't say what the MH is because they're kind of all over the map. You know, I'm sure they'd like to say that all of them are 500, and they're not. You know, so that's probably the reason they don't want to say, you know. See, now, like with this one, they're saying it's 500 mH. Original Dunlop drop-in. I believe this is just a toroidal. I'm not sure. Maybe you guys can correct me if I'm wrong here. But I don't think this is a halo. By the way, Amplified Parts is Antique Electronics Supply in Tempe, Arizona. It's the same company. Now, here these guys say the MH rating is about 563 MH. So they're more truthful here. I think they're being more truthful about it being closer to 570 for a red phasal. So this is your red phasal, basically your drop-in red phasal replacement. Okay, and it's cheaper. It's $8. Now, just a shout out. I am the founder. Not bragging, but love my boys in Guitar Pedal Builders. It's a Facebook group. You guys can join. You have to answer a few questions to join, but you can join us. And we will help you with your pedal building projects. That's what the group's all about. We help each other out and work on projects together. It's fun. All right, so back to inductors. The closer we get to 500, the closer we're going to be in that sweet spot for being in Clyde McCoy specs. However, like I said, a little bit hotter of an inductor means that it's going to work better with distortion. And for some people, that's key. That's why these are all a little bit hotter, you know, than 500. Avoid the yellow phasal. It's not my cup of tea. It's not a lot of guys' cup of tea. Like I said before, there's a reason that Dunlop does not install the yellow phasal in any of its production pedals. If it was great, they'd be installing it in their production pedals. Okay? So just avoid it, you know, unless you have to have that vintage sound. And even if you have to have that vintage sound, why not go for a film can inductor? Which you can't find anymore, I'm sure. Let me see if I can find a picture of a film can inductor. Here's a film can inductor. There'll be a silver. Here's another one. They're in the older units for the most part. Well, you know, you'd have to find this part, which would be near impossible. Here's a good picture of one. This guy, they're calling it a trash can inductor in this one. Maybe that's what they call them in the old Vox V8 846s. But who knows, man? I mean, you can always roll your own, dude. Okay, now here's the old stack of dimes inductor. Okay. And these used to be sold by Small Bear. And they seem to be pretty much impossible to find now. Joe Gagan is the king of fucking Wawas. If you haven't checked out Joe's stuff, check out Joe Gagan, man. He is king when it comes to this stuff. And wah metal, you know, having a real Clyde McCoy spec wah. He rolls his own inductors. The guy is truly, you know, a brilliant guy to talk to about this stuff. If you're not willing to do the work yourself and you just want that sound, go talk to Joe. You know, I just do basic mods. Joe will sell you the complete, you know, the complete package. In fact, I was checking out some of his stuff yesterday. Okay. So let's check out Joe's stuff, just to give Joe some props here, man, because this ain't all about me. It's about other people in the community who specialize in this stuff. You know, see, like he's got a drop-in gate. You know, like this is already pre-modded, man, with true bypass. You know, you just drop it in. Here's another one, drop-in deluxe version pre-modded. You know, drop-in V847 Hot Rod Clyde, now with a halo. So this actually has that really rare stack of dimes fucking halo inductor on there, man. That's cool, right? Hot Rod Clyde. So there's your little nameplate you put over the Vox nameplate on the front of the wall. So this is kind of comes with everything needed to modify that wah. And then of course he has already modded complete units like this. You can see he's removed the like we were saying before, he's removed the buffer stage. See that? This is the buffer stage right here. And then he's wired the pedal true bypass. That's what this is right here. This is a 3 PDT switch. Looks like he's got trim pots for some of the values. Looks like he has replaced that with a 68K, I think. I can't really tell from here. You know, again, I'm just showing you guys Joe's stuff. You know, we can, you know, a lot of us, if you're watching my videos, you can probably do this yourself. But there are some of us who watch my videos just to get ideas on tone, and that's okay too. So here's the Betty G new germanium crazy wah. I don't even know if they maybe replaced the diodes with germanium. No. Okay, see this this transistor, for whatever reason, I don't, you know, Joe knows this stuff, so don't ask me. But he's changed this transistor with the germanium can. This is an old germanium transistor in the circuit. I was thinking maybe he changed the diode to a germanium diode, but that wouldn't, you know, that would make the clipping, well, this thing doesn't even really clip, so anyway. Okay, here's the Joe Sonic. Every one of these is a little different. Here you can see he's got a red phasal, and he's changed that. He's changed the capacitor over here to a really large cap. I'm not sure. Maybe this. I don't know if that's a metal film cap or what that is, but maybe this sounds better with that type of cap in that in the circuit. He's removed the input buffer again. He's got the trim pots. Boom, boom, boom. So he can kind of set it to where he wants it. I would assume that's because he can't get a fixed resistor, in the right value. Either that or every one of them is a little different based on the inductor. Because, like I said, the inductor is not always going to be 500 or 570 or whatever the hell they say it is. It's going to be a little bit all over the map, as all components are. A lot of people, they come to me, they go, I don't know what I put a 10K resistor in there, and I'll pop the 10K resistor out, and I'm like, it measures 14K on the meter, or it'll be a 10 UF capacitor, and I'll throw it on my meter, and it's 15 UF. So, components shift out of value with age, and not only that, but they can be that way from the factory. So get yourself one of the little, I don't know where mine is because my desk is a friggin' mess right now. But get yourself one of the little parts testers where you can, I wonder if I threw it back in here. Yep, there we go. Get one of these. Wait, I'm trying to get one of these guys, and you can test everything and know what the value of it is easily. You just pop your component in here, in here, and then you flip that down, press the button. It's going to test the component. It tells you what it is. It's saying nothing's there. It's a great little tool to have. You can get these on eBay for next to nothing. They're peanuts. I think this one was, I want to say it was like $8 or $9 for the circuit, and then I paid $3 for the housing. So you're not even out 15 bucks, and you've got a pretty cool component tester that'll test transistors, capacitors, resistors. It's basically a good ESR meter without spending a ton of money. Plus, it tells you what the component is. A lot of times, I'll pull stuff out of my parts piles, and I'll go, "What the hell is this thing?" I can't find anything on the part number, and I'll throw it in there and I go, "Oh, it's a dual diode," or it's a good tool to have. And it also tells you if something's out of spec. So here's one I was just talking about, people using paper and oil. Well, I was kind of bagging on people who want to use paper and oil capacitors, but maybe he's on to something. I never discount what other people are doing, because the proof's in the pudding, and a lot of people who get a Gagan wah pedal really enjoy the Gagan wah pedals. I mean, this guy does some fantastic work. That's cool, man. I mean, it just looks cool. Even if it doesn't, provide that big of an advantage, it does look freaking cool. You can see he's got a couple of silver mica capacitors kind of sandwiched in between these paper and oil capacitors. I believe these are Russian. I haven't seen these, so I think these are probably, it's so hard to get, new old stock American paper and oil capacitors now, that these are probably old stock Russian paper and oil capacitors that he's used in the circuit, which is fine. And again, he's got an old inductor in there. He's got I think that's the stack of dimes. I'm not sure. And he's got the 2 trim pots here. It looks like he didn't put in the 3rd one maybe on this one. Yeah. It's also good to look at other people's work for ideas. I do it all the time. I sit down and I look at other people's ideas and I go, oh, that's cool. I wonder how I could tweak that to my own preference. But you can see a common theme here with his stuff. He's removing that output buffer first and foremost. That goes bye-bye. No more no more input buffer. Okay. Then he's using a ceramic disc capacitor right here for some reason, and that could be for tonal reasons. I'm not sure. He seems to like replacing this capacitor right here too with a higher voltage. For some reason, maybe it's just what he has in his parts bin, but he's putting a higher voltage cap in each one of these circuits, and I believe this is like a polyfilm. I think it's a polyfilm cap. I could be wrong. Looks like the 4.7 stayed the same. Both of the transistors are the same in this one. He didn't replace this one with a germanium can, like for example, again. And then he's got a red phasal in this one. So, you know, even Joe, I'm sure, knows that, you know, you can see this Joe Sonic drop-in kit is cheaper, but I think even he knows that, like, the red phasal is still a good sounding inductor. I mean, it's still a good option. See, this one also uses the red phasal. Then he's got some interesting something interesting going on here with this this dip switch. It looks like it's some kind of a capacitor selector. Yeah, I don't know what he's got going on there. And then he's got a couple of these older, maybe, yeah, they're silicon cans. I don't think those are germanium. Those look like old. They look like old Motorola cans. These two transistors should look like old Motorola cans or something like that. Maybe even Texas Instruments. They made them in, you know, a lot of companies made that style. This is an interesting one for sure, and you can see he's got a point. He's used a Sprague, which is a German. We call them orange drops sometimes, but he's used a Sprague .22 UF in that position. Looks like he's stacked maybe two capacitors together to create a specific value right here. Like he's got the silver mica alongside another cap right there. Anyway, I'm going to close this one down now, guys. Hope you got some cool ideas on modding that wah-wah. And get your wah-wah-wah-wah-wah-wah tone. Alright, later, dudes.